Myself, Dr. Sivamani, Associate Professor, Department of Biomedical Engineering, KIT, Kalinger Karnataka Institute of Technology, Coimbatore. In this video, I am going to discuss about bipolar junction transistor. A bipolar junction transistor is a three-terminal semiconductor device in which the operation depends on the interaction of both majority and minority carriers, hence the name bipolar junction transistor. So it can be used as either an amplifier or a switch. Transistor is current controlling device. The transistor can be either NPN or PNP type. So the figure shows the NPN transistor. In this symbol shows the PNP transistor. The three layers of BJT are emitter, base, and collector. Base is a very thin compared to the other two layers. So base is slightly doped. Emitter is heavily doped and collector is moderately doped. In NPN transistor, emitter and collector are made up of N-type semiconductors. Base is P-type. Alternatively, in PNP transistor, emitter and collector are P-type material and base is N-type material. In both the types, NPN and PNP are extensively used, either separately or in the same circuits. Bipolar junction transistor has the two junctions, this emitter-based junction and collector-based junction. Here shows the construction of the NPN and PNP transistor. The two junctions are emitter-based junction and collector-based junctions. Here the arrow direction from P to N, like diode. In this figure shows the different transistor package. Coming to the transistor operation of NPN transistors we discussed here. For normal operation, emitter-based junction should be forward biased and collector-based junction should be reverse biased. So the depletion width at emitter-based junction is narrow and depletion with collector-based junction is wide. Consider NPN transistor operation. Here, this VEB voltage, emitter-based voltage, forward bias the emitter-based junction, and VCB, that is a collector-based voltage, reverse bias the collector-based junction. The forward bias applied to the base emitter junction of NPN transistor causes a lot of electrons from the emitter region to cross over to the base region. As a base is slightly doped with the P-type impurity, the number of holes in the base region is very small, and hence the number of electrons that combine with the holes in the P-type base region is also very small. Hence, a few electrons combine with holes to constitute a base current IB. The remaining electrons cross over into the collector region to constitute a collector current IC. So, total current is nothing but a IE equal to IC plus IB. There are three currents can be identified in bipolar junction transistors are emitter current, base current, and collector current. So current direction in NPN and PNP transistors. In NPN transistor, the current coming from base to emitter. In PNP transistor, the current flows from emitter to base. In both the types, total current IE equal to IC plus IB. Next, transistor configuration. In BJT has a 3 terminals. For 2-port applications, we need 4 terminals for input and output. Accordingly, 3 configurations are common base configuration, common emitter configuration, and common collector configuration. In common base configuration, base is common for input and output port. In common emitter configuration, emitter is common for input and output. Common collector configuration, collector is common for input and output. So consider common base configuration. In common base configuration, base terminal is common for input as well as the output. Here, the base emitter voltage is the input voltage and emitter current is the input current. Collector base voltage is the output voltage and collector current is the output current. From this configuration, we measure the input characteristics and output characteristics. For input characteristics, the graph is plotted between the input current, that is IE, versus the input voltage, that is VEB, by keeping the output voltage as different constant like 0, 10 volt and 20 volt. From this input characteristics, we measure the input resistance, that is Ri. Input resistance Ri is nothing but a variation of input voltage to the input current with respect to output voltage is constant. This figure shows the output characteristics. The output characteristics is plotted between output current versus the output voltage at constant input current. Here we identified the 3 regions are active region, saturation region and cutoff regions. In active region, emitter base junction forward bias, collector base junctions reverse bias. So in this region, both the collector current as well as the collector base voltage is positive. If IE increases means IC also increases. In cutoff regions, both the junctions are reverse biased. Here IE equal to 0, then IC equal to ICB0. That is the collector current is nothing but a reverse leakage current. In saturation region, both the junctions are forward biased. Here IC decreases exponentially. From the output characteristics, we measure the output resistance R0. That is the ratio of the output voltage to the output current with a constant input current. Then current amplification factor alpha is the ratio of the output current to the input current with output voltage is constant. So both can be measured in common base configuration output characteristics. So what is a transistor biasing? So applying external DC voltages to ensure that transistor operates in the desired region. So which is the desired region? For amplifier application, transistor should operate in active region. For switch application, it should operate in cutoff and saturation.